Good morning. Myself, Professor Sanjeev Kumar Trivedi, Head Department of Electronics and Communication, Faculty of Engineering and Technology, Khwaja Mohideen Chishti, Language University, Lucknow. Dear students, today we are going to discuss biasing in PN junction diode. What is biasing in semiconductor diode? With the help of diagram, you can see PN junction diode, P and N. P is anode and N is the cathode. Biasing of PN junction diode. Forward biasing incorporates the connecting of a positive voltage potential to the P-type material and a negative to the N-type material across the diode, thus decreases the width of the diode. In contrast, reverse biasing condition involves the connection of a negative voltage potential to the P-type material and a positive to N-type material across the diode. Thus, the increase the width of the diode. Now, I just want to tell you the difference between the forward biasing and the reverse biasing. A forward biasing reduces the strength of the potential barrier of the electronic field across the potential, whereas a reverse bias strengthens the potential barriers. A forward bias has an anode voltage that is larger than that cathode voltage. In contrast, a reverse bias has a cathode voltage that is larger than the anode voltage. A forward bias has a substantial forward current while a reverse bias has a minimum forward current. The deflection layer of an anode is substantially thinner while in forward bias and much thicker when in reverse bias. Forward bias decreases a diode resistance and the reverse bias increases the diode resistance. The current flows effortlessly while in the forward bias, but reverse bias does not permit current to flow through the diode. The level of the current depends on the forward voltage while in the forward bias. However, the amount of the current is minimal or negligible in the reverse bias. Now, what are the principles now? If the P region anode is connected to the positive terminal of the external DC source and the N side cathode is connected to the negative terminal of the DC source, then the biasing is said to be the forward biasing. Due to the negative terminal of the external source connected to the N region, free electrons from N side are pushed toward the P side. Similarly, the positive end of the supply will push holes from P side towards the N side with increase in the external supply voltage V, and the more number of the holes P side and the electron N side start traveling towards the junction. The hole will start converting the negative ions into the neutral atom and the electron will convert the positive ions into neutral atom. As a result of this, the void of the deflection region will reduce. Due to reduction in the deflection region, width, the barrier potential will also reduce. Eventually, at the particular value of V, the deflection region will collapse. Now, there is absolutely no opposition to the flow of electrons and the holes. Hence, a large number of electrons and the holes, means majority carriers, can cross the junction under the influence of externally connected DC voltage. The formation of deflection layer in the PN junction, you can see with the help of this figure, it is divided into the two parts. One is negative immovable ions and the second one is the positive immovable ions. In negative ions, you can see holes, minority carriers and electrons. In positive immovable ions, you can see free electrons, minority carriers, that are holes, and in between you can see a line that has been defined with the PN junction, and downwards it is written that is a deflection layer. The formation of deflection layer is done. At that instant PN junction formation, the free electron near the junction in the region begins to diffuse across the junction into the P region, where they combines with holes near the junction. The result is that N region loses free electrons. That creates a layer of positive charge, that is pentavalent ions, near the junction. The P region loses holes, and the result that there is a negative charge, that is trivalent ions near the junction. The shaded region on the both sides of the junction below contains only immovable ions and no free charge carrier such as electrons or the holes. In other words, this region is depleted of free charge carriers. Therefore, region is called a depletion region. Once p-n junction is formed and a depletion layer is created, the diffusion of free electron stops. The positive and the negative charge set an electrical field. In the figure, with the help of figure, you can see the voltage is varying from place to place, in which breakdown region, breakdown voltage, leakage current, avalanche current, and the reverse voltage, forward current voltage has been defined in the figure. You can see from where the voltage is being cut after a particular point, voltage shut down. You can see a breakdown region, a breakdown voltage can be seen, and after that there is an increase in the voltage that's showing upward direction, that is the forward current. Thank you.